Hello and welcome to the next tutorial. Today we are going to look at the cam switch functionality, which comes in the TechCam switch library included in the ProgRock project. And how we will get there is, first of all, we need to go to settings and cam switch, and here we can see the settings for the cams that we have. We have position cam, which switches on the specific position and switches off at a specific position, and a time cam, which can switch off on a specific position for a defined time. And then we have as well a position cam, which has also the possibility to do a dead time compensation in case of delay due to pneumatic switches. And so let's go through all these cams and let's take a look at the function in more detail. So first we let the master run with 10 increments per cycle, use a gear, and let's switch on our drive, homing, and let's start. So now if we go to the cam switch page, we can see it's moving. So the master is doing a linear movement. And yes, so let's try the first cam. When we say, okay, we want to switch on the cam at 30,000 increments and switch off at 40,000. And when we turn the cam on, you can see on 30,000 it switches on, and 40,000 it switches off. And yeah, if we now take a look in the PLC project, we can see the technology functions right here in the event technology POU. And there we have the cam switch functions. The first one, the position cam, is linked to the TB channel, which is basically just a position cam that can be switched on and off. So we don't need to do a lot of configuration here. And the channel time is also more or less not that heavy to configure, so we just need to give it a position, the resolution, the interrupt time of the task that is used, the position when to switch on the cam, and here is the time that the cam should be switched on for. And the cam switch is basically the biggest function block, which enables the user also to do a dead time compensation with the delay input. And in order to do this configuration, we also have a small state machine down here. In state machine cam switch, you can see channel. It's just, if it's enabled in the visualization, it will get the on and off value and the position. So if I enable it again in the visualization, you can see it's enabled and it's running. Yes, so the next one is the channel time. So let's take a look at that in the visualization. So we can also say turn on at 30,000 increments for 200 milliseconds, for example. And if we do that, it will turn on the cam for 200 milliseconds. And we can also maybe make 1000 milliseconds so that we can see it a little more precise. Just have to wait until that point is reached again. And you could see it's way longer in that the cam is turned on. So the position cam with dead time compensation, let's also say 30,000 increments, and we have a dead time of 200 milliseconds. And if we turn that one on, it will also switch on at 30,000 minus the dead time. But we cannot see anything here, and you might ask yourself, why is that so? The reason for that is that the cam switch is just switched on or turned on at the output for one cycle, and you can see it here. Every time that point is reached, I have a counter here which shows me, okay, the output is enabled at that point, and we have the cam out for one cycle. So yeah, we could of course make or put another graphic into the HMI in order to show that it's enabled, or also just put the cam counter on the HMI in order to see that something is happening if you need the feedback. That's possible. So yeah, and you can see the cam switch is a little bit more complicated. So as well, we wait for the command. If it's enabled in the HMI, we set the master velocity, set the cam switch to ready, give it the cam position, the period, how many increments per period, and the delay. And then we have the set velocity and actual velocity of the master. So this is the master input, as we can see here, and the master output, which is scaled from increments per cycle to increments per second for the function block. And here we have a little division avoidance in order to, because we divide by the acceleration here, and if the acceleration is 0, we get a problem. So yeah, we get the acceleration time in order to enable the function block also to do the dead time compensation during the acceleration and deceleration. And yes, that's basically it about the cam switch functionality.